So how do I get the CP of just the protein? Perfect. Okay. What Amanda said, to get the actual CP of just the protein itself, just the part I'm interested in, I need to do the heat capacity of the sample, buffer and protein, minus the reference, just the buffer. Okay? Take the piece that has both, subtract out the background, the buffer part, and I just have the protein left. This includes solvent effects. Okay? I can't discern these out. When I calculate this from my instrument, it is taking into account what's going on. It's taking into account any interactions between my protein and the water. Okay? And it's not able to tease those out, but it will encompass those. Okay, and so this is the plot that we saw before, temperature versus heat capacity of the protein. Remember, this piece is actually this whole piece. It's really a difference between the two cells, okay, in kilojoules, mole, Kelvin. So it's really a difference in CP between our two pans or cells, whatever you want to call them. And it looks something like this. We have the things all folded up neatly. There's this big piece. I've severely exaggerated this. So here's the folded protein. Here's the unfolded protein. Okay. There's some difference in heat capacity between the folded and unfolded state. Okay. It's not the same as this change in CP. We're also going to define another change in CP between a baseline curve and this peak. There's a lot of delta CPs going on, so try to keep track of them as we go, okay? It's can be a little bit confusing. What did we call this temperature here? At the top of the peak, the peak of our CP curve, we called it the melting temperature. So if you're melting plastic, it makes more sense. Like, I'm literally melting it. I'm going from a solid to a liquid. In this case, we're talking about denaturing. Okay? We're at the unfolding state, but we still call this T sub n, or the melting temp of our protein. So let's switch back to the slides, take out a piece of paper and answer 2 true-false questions with write a little bit of an explanation. Write your reasoning down next to it. Okay? So 1, this is the curve I just drew for you, right? Point C on the DSC curve represents the point when the proteins are halfway unfolded. Right? It's melting temp, we already defined that. And then the next one is the change in free energy is 0 at the melting temperature. So take a minute and answer those with a bit of explanation. Talk to your friend.
I know, but I think
Oh, yes. Oh, I see. You're saying
Who came up with an answer for the first one? We'll do this one first. So point C on the DSC curve, which we already said, point C was the melting temperature, represents a point when the proteins are halfway unfolded. Who thinks that this is true? Who thinks that this is false? That is the correct answer. Why is it not the point when they are halfway unfolded? What is that? Why is this wrong? What's your reason?
they're either folded or unfolded. So
Perfect.
that's like half would be in the folded state, half would be unfolded.
That is exactly right. We're not talking, the proteins are not halfway unfolded and then they unfold their other side. This is a two-state reaction. Okay, so even if you wrote false, you didn't maybe give this explanation, then you wouldn't have gotten it right on a homework or an exam. There's only two states, okay? Half of them are folded, half of them are unfolded. None of them are partial. We were only considering this as a two-state situation. So I would write this as false, there's no intermediates. So, unfolding is a cooperative process. Once it starts, it's really rapid. We're gonna assume it's completely unfolded. Yes?
But are half of them folded and half of them are unfolded? Or is
It happens very rapidly, and so while this is showing like there's a wide range of temps and it's this really nice peak, yes, it's a reasonable assumption. Yep, that half of them are unfolded and half of them are folded. But it happens pretty quickly. Here they're all folded, here they're all unfolded, and this difference here is pretty stark. Yeah, it definitely is like I said, a cooperative process that does happen really rapidly. So it's reasonable to say yes or no. So because half are unfolded, half are folded, we could say then that the concentration that are folded is equal to the concentration that are unfolded. Okay. So then what is our equilibrium constant? We're unfolding now. Okay, so then what is the answer to the second one? True or false? Change in Gibbs free energy is 0 at the melting temperature. Okay, this was our relationship between an equilibrium constant and standard state change in free energy. If this piece is 1, this whole thing is 0, the change in free energy at the melting temperature is 0. So this one is true. Good job. Looks like everybody nailed it.